Welcome to our Energy, Work, and Power unit. In order to fully understand energy, we first need to define energy itself and the two main types of energy. So, what is energy? Energy is the ability to do work, which is a scientific concept, or to cause a change. Eventually, we're going to learn that work is a transfer of energy through motion. Energy is measured in joules, which is abbreviated with a capital J. And how much is a joule of energy? Well, 1 joule is equal to 1 Newton meter. This unit is related to the physical concept of work, which is our last target for the unit. Now, physics is based on conservation laws. And in this particular unit, we're going to focus mainly on the law of conservation of energy, which states that energy is neither created or destroyed, meaning that energy can easily change from one form to another. So, for example, solar panels take light energy and make it into electrical energy, which powers your iPod or iPhone. There are two broad categories of energy. There's potential energy and kinetic energy. Potential energy can be further separated into 3 different types of energy: gravitational, elastic, and chemical. But what is potential energy? Potential energy is energy stored in an object due to its position. So if we have gravitational potential energy, that means energy is stored in an object because of where it's placed, meaning it's based on the object's height. So for example, a roller coaster sitting on top of the first hill right before the big drop has lots of potential energy. But it doesn't have to be as dramatic as that. Another way you can get gravitational potential energy is standing on a table or a stool. It may not be as much as the roller coaster, but there's still some potential energy there. In terms of math, which you knew was coming, there's a formula for gravitational potential energy. So we'll say that potential energy is equal to the mass of the object times the gravitational pull of the location you're in times the height of the object in meters. The second form of elastic potential energy is elastic. So that's energy found in objects that want to bounce back when they're stretched or squeezed. So, for example, if you take a rubber band and stretch it out, that has a lot of elastic potential energy because it's going to want to bounce back to its original position. A second good example, especially for the athletes, is muscles. So muscles are based on contractions and dilations. So when you run or even walk, your muscles dilate and contract. And that's a form of elastic potential energy. The third type of potential energy is chemical potential energy. And this is a type of energy that's stored in the bonds between atoms and molecules. So for example, food is my favorite example of chemical potential energy. And though that energy is in the form of calories. Another really good example, because you guys are all future drivers, is fuel or gasoline. Energy is stored in those bonds, and when you put gasoline in your car, the engine breaks apart the bonds to release that energy. The second broad type of energy is kinetic energy, and that's the energy of an object in motion. It depends on the mass and the velocity of the object. This should make sense. Naturally, if an object exists, it's going to have mass, and if it's moving, it's going to have velocity, which is why kinetic energy depends on the mass and velocity of the object. There is a formula to solve for kinetic energy, and so kinetic energy is equal to 1/2 times the mass of the object times the speed of the object squared. In our next class period, we'll learn how to calculate potential and kinetic energies of different objects. There's one way to figure out if you have given an object, you should be able to classify it as either kinetic or the 3 different types of potential energy. In order to do so easily, it's really nice to follow a flowchart. You'll always start here, and you'll ask yourself, is the object moving? If your answer is yes, it's already kinetic energy. If the answer is no, then you need to ask yourself some more questions. Is the object a type of fuel? If yes, then it's chemical potential energy. If not, you have to ask yourself some more questions. Is the object placed above ground level? If yes, then it's gravitational potential energy. If no, there's one more question you have to ask yourself. Is the object stretchy or bouncy? If yes, then it's elastic potential energy. If you said no to all these questions, something probably went awry, so you'll have to start again. On the back of your note sheet, there is a picture. And what you're going to need to do is to draw in these 4 boxes and label them as kinetic energy, gravitational potential energy, chemical potential energy, and elastic potential energy. So for example, I'm going to make kinetic energy red, gravitational potential energy green, chemical potential energy yellow, and elastic potential energy blue. And what I'm going to do with my colored pencils is I'm going to color in these objects that are numbered with what type of energy they are. So for example, the sun, if I look back at the chart, is the object moving? No, it's not. Is the object a type of fuel? Yes, it is. So the sun I would label as chemical potential energy. And in looking at my key that I made chemical potential energy yellow. So I would color in the sun as yellow. You have 7 other items to identify. When you're done with this, you should check your answers either on the board or with your teacher.